Hi everyone, so I am going to explain what I found for data for the temperature zones that I have um, concluded my data on. So basically to start, I did draw out the map where all the temperature zones were located and highlighted them. So I have the Endurance Array, I have the Pioneer Array, and I do have the Argentine Basin Array. So I will start with this most likely, but I just want to explain what each section is before I go into detail on each section. So we have my title, which is the temperature zone chlorophyll data. Like I said, we have Endurance Array in the temperature zone, Pioneer Array in the temperature zone, and Argentine Basin Array in the temperature zone. Now, the Endurance Array is located in the North Pacific Ocean. We have the Pioneer Array in the North Atlantic Ocean, and then we have the Argentine Basin Array in the South Atlantic Ocean. So, to go from here, I actually think I'm going to start over here so you guys can understand based on the data that I collected that we had in Figure 1 from 2015 into 2016 for the temperature zones that I just talked about. So specifically for Endurance, on the Endurance Array Station in the North Pacific, the North Pacific, near that station, you can see that the chlorophyll levels go up and down, which definitely could mean that this is likely because of the different temperatures, the winds coming across, but also the phytoplankton not levels, but activity is all based on sun, algae, anything of that. Like that is all contributes to how the chlorophyll levels go. So if phytoplankton, say, has a bunch of sun, then the chlorophyll levels are most likely going to be higher. And sorry, it's so like tilted. So this is, like I said, based on the year 2015 into 2016. So now we have the Pioneer Array in the North Atlantic Ocean, which is definitely going to be different. So in the North Atlantic, near that Pioneer Array station, you can see that the chlorophyll levels start up higher, which probably most likely means that the temperature of the sun, the algae was all up there, keeping the phytoplankton organism eating and higher levels. So, which would cause higher levels of chlorophyll, excuse me. So, as it goes into the year of 2015, we also see a decrease, and it just decreases and then stays pretty steady throughout the year, which would mean that there really wasn't a huge difference in temperature, sun reflection, any of that, causing the phytoplankton to die out, have to move, all of that type of different stuff. And again, I just put on each one that data was based on the year 2015 into 2016. Now to quickly go back to this, and then I'll do the Argentine array, basin array. This isn't completely to scale. This was a rough drawing of, and you can see like the other places that would be for the polar zones. This is temperature zone, so it's not completely to scale, but it is a rough representation of where these would be in each part of that ocean zone. So next, we will go over to the Argentine Basin Array in the South Atlantic Ocean. Basically, in this one, this station, the Argentine Basin Array, you can see that the chlorophyll levels do stay pretty low. Now, this is most likely due to not having enough sun, the algae could be different, all of that could be just lower. But it does stay consistent. So that could just be how that part of the ocean functions, like I said, by the sun, by algae, by wind, by temperature, all of that grow into phytoplankton, which affects the chlorophyll levels, and that is why we're seeing it stay on the lower side, which would explain the levels being so low. But those are the three main stations in the temperature zone that are super important to talk about based on the data that we saw in 2015 through 2016. Like I said, they all change, but it's all based on the phytoplankton, how it's living, surviving, and all the different things. And based on what we learned too during this course, nitrate levels, dissolved oxygen, fluorescence, all of those, temperature, they all play into how different things grow and survive. So that's pretty much the same thing when it comes to chlorophyll levels. It all will be higher, lower based on the different zones, temperatures, winds, any of that. It's all going to be different based on what it is at hand. Seasons change, so when seasons change, things like the chlorophyll levels will change to grow and incorporate how it's supposed to be. I mean, it's just a season. When seasons change, so don't levels of different things, just like the nitrate levels, the dissolved oxygen, the temperature, the fluorescence, those all change throughout a specific time period. And I can only imagine if we looked in depth into those seasons, we would have seen way different data that would have showed how it really changed instead of over a very long period of time. So, last thing I am going to go over is my 250 word kind of introduction. I will read it and then kind of explain, or it pretty much explains itself, but I'll read it. So I have studied the chlorophyll data in the temperature zones from the years 2015 into the year of 2016. My poster explains what each station represents for chlorophyll levels. Like I said, it explains which each station represents for chlorophyll levels during this year and the potential. Oh, sorry. Let me rephrase that. I have studied the chlorophyll data in the temperature zones for the years 2015 into the year 2016. My poster explains what each station represents for chlorophyll levels during those years, and the potential reasons why these are the levels during that year. As you can see, at the station Endurance Array located in the North Pacific Ocean, their levels are up and down at a higher level. This is likely due to winds and temperature changes coming across the ocean, as chlorophyll levels are usually higher when exposed to temperatures and wind changes. Next, you can see at the station Pioneer Array that the chlorophyll levels start higher earlier in the year 2015, only to decrease and stay constant into the year of 2016. This is usually due to upwellings and how it affects phytoplankton through the year, as you can see that the levels go down as the year comes to an end. That usually means that something like upwellings, winds, temperature changes to phytoplankton took place and caused the chlorophyll levels to decrease and stay around the same. Last, we have the station at the Argentine Basin Array that has constant low chlorophyll levels. This would be because there's not much activity of phytoplankton, which is what really determines chlorophyll levels. Over on the right hand of the poster, you can see a hand-drawn map, not to scale, including where all stations are located throughout the temperature zones for these specific stations. Now, so that's my 250 response introduction to all of this, explaining what my poster is, but also to say it's all based on coastal and oceanic places in the ocean. So coastal is going to obviously have different data, different things that happen. Unlike if you go deeper into the ocean, that's what's going to happen. I mean, coastal zones are different than oceanic zones deeper into the ocean. But other than that, that is what is going on with the data that we were given. Thank you.